Good day to all my fellow scientists. My name is Kate Ashley Liao, a grade 12 STEM student. Welcome to my science laboratory. Today we'll be discussing Archimedes Principle and the concept of buoyancy. Before we start, let us explain the definition of Archimedes Principle. Archimedes Principle deals with the forces applied to an object by fluid surrounding it. This applied force reduces the net weight of the object submerged in a fluid. It is also this physical law of buoyancy that helps us understand how ships float in water. Buoyancy, on the other hand, is the force that causes objects to float. It is the force exerted on an object that is partially or wholly immersed in a fluid. Buoyancy is caused by the differences in pressure acting on opposite sides of an object immersed in a static fluid. It is also known as the buoyant force. For this project, the materials are easy to find and prepare. That is why to those who are interested and curious, you can all try this at home. First, we need 3 glasses that have the same shape and size. Also, let us prepare a generous amount of tap water. Next in line are 3 fresh eggs that are estimately the same size and shape. Lastly, don't forget the salt. For the first setup, I am going to fill my glass with approximately 250 ml of water. We measured it using a measuring cup as you can see in the video. I'm going to dilute the water with 6 tablespoons of salt. So I stirred on the salt water for roughly 2.5 minutes probably, and after that you see that it's diluted. So now, I'll take this fresh egg in and drop it inside of this glass. We see that it floats to the top, and I can push on the egg, and I can push even harder than the egg, and it's always going to come up back to the top. Now, this is because of the force of buoyancy on this side is actually equal if not greater than the gravity that is pushing down on the egg now. The concept behind this experiment is that an object will float in fluid if the density of the object is less dense than the density of the liquid. For the second setup, I am going to fill my glass approximately with 250 ml of water. We measured it using a measuring cup. Now, same as we did on the first setup, let us take 1 fresh egg and drop it. You can clearly see how it slowly sinks at the bottom, and that's because the gravity force is pushing down on the egg and the water, but the buoyancy force from the liquid is trying to hold it up, and that's why the egg doesn't drop as it is if it was dropped on the floor. Since the gravity force is still stronger than the buoyancy force, the egg still goes to the bottom. The concept behind this is that an object will sink in a fluid if the density of the object is greater than the density of the fluid. Last but not the least, the last setup. Let us prepare the same amount of water but dilute the solution with 3 tablespoons of salt instead of 6. Now, same as we did on the first and second setup, let us take 1 fresh egg and drop it. This is a little bit trickier since the egg needs enough salt to be submerging but not floating. As you can see, as we drop the egg, it is neither floating or sinking. This is because an object will be in equilibrium at any submerged depth in a fluid if the density is of the object and the fluid are equal. Let us look back to the setups we executed. The water with no salt diluted made the fresh egg slowly sink at the bottom. For the setup where it was diluted with 3 tablespoons of salt, the egg appears to be submerging but not floating. And lastly, the setup with 6 tablespoons of salt made the egg float up to the surface that even if I push on the egg, it's always going to come back up to the top. Why is that? What changed besides the salt? You know well, as exactly as it is because of the salt. Because we can see that the force of buoyancy is equal to rho GV, where rho is the fluid density, V is the volume of the water displaced inside the glass, and G is equal to gravity. Now, between these two things, you're like, okay, well, what exactly did this all do? You know, to change this situation with egg to float rather than to sink is by adding salt. We change the density of the water because the density is equal to mass over volume. The volume of the water stayed the same on each setups. All have equal amount of water, but by adding salt, it changes the mass which increased the density. When we look at this force of buoyancy is equal to rho GV equation, where rho is the fluid density, G is equal to gravity, and V is the volume of the water displaced, we can watch how the volume of water displaced on all of the cups, and that they are equal. What I'm trying to show you is that the same gravity is used in these setups, and the same volume of the water is being displaced by the eggs because they are all roughly the same size and shape. The only thing we're changing is the fluid density, which I previously described as changing, simply because we changed the mass from the salt. On the force of buoyancy, we were able to see that the cup, as I showed you with no salt in the water, sank the egg, whereas it tried to stay out, but it physically could not because of the fluid density inside of the cup. It still displays the same amount of volume and the same amount of gravity. Now on the other cup, we saw that by changing the density and using roughly the same egg and obviously the same gravity, we were able to see that the force of the fluid density inside was changed relative to the mass by adding salt, which then allowed the egg to suit up and float. Now, this is the same kind of thinking that they have whenever we think of large barges and ships in the city by shipping over containers. Now, you would think to yourself, how did I even get these big ships of massive metal to float and stuff? Well, they don't use that same principle relative to density, but rather they think of the void with water displaced. They can't change salt water, right? Like it's impossible. So what they do is that by taking that force of buoyancy equation, which is equal to rho GV, they focus on that V. They take these big boats and barges and whatnot, and they make them massive enough to displace tons and tons and tons of water, and by displacing that much water, they are therefore affecting that equation so that the boats can float. So that's the end of my demonstration, and thank you for watching!